Hello all, hope you all are doing good. In today's session, we are going to learn an important topic in database management system, which is functional dependencies. And with the help of these functional dependencies, you are definitely going to understand the concepts of decomposition and normalization in further sessions. Firstly, let us move into the topic and know what is functional dependency. In database management, functional dependency is a crucial concept that helps in the design and understanding of relational databases. Here we have the formal definition for functional dependency. Let R be a relation schema and let X and Y be the sets of attributes in R. We say that Y is functionally dependent on R and it is denoted by X tends to Y. If for every valid instance of X, there is exactly one corresponding instance of Y. So we will understand what is functional dependency by taking an example. Before that, let us understand the terms that are involved in it. Here it is said that R is a relational schema. What is meant by relational schema? It is a schema which describes about the table. We know that table contains rows and columns. The columns are defined as attributes in a relation and rows are defined as tuples in a relation. So which means R is a relation contains attributes namely X and Y. And it is said that Y is functionally dependent on X. Here, this is the notation arrow mark is used to denote functional dependency. Whichever attribute is present at the right side of this arrow mark is known as dependent. And the attribute that is present at the left side of this arrow mark is known as determinant. How you are going to read this X tends to Y? Formally, we read this as X determines Y. Otherwise, Y is functionally dependent on X. Now let us understand what is functional dependency with the example. Here in the example, we have three attributes, namely roll number, name, and course. Also, there are certain set of values given for every attribute. Now there is a question, which of the following is functionally dependent? Among the options that are available, you have to decide which one is functionally dependent. We have attributes like X and Y, and you're going to apply the formula for the given example. That is, if there exists T1 dot X which is equal to T2 dot X, then there must be T1 dot Y which is also equal to T2 dot Y. If this is satisfied, then we can say that this attributes X and Y are functionally dependent to each other. The same formula we are going to apply for the given question. Now, what is the first one? We have roll number tends to name. Let us check whether this is functionally dependent or not. So, you are going to consider any of the tuple from the roll number column. So as we have tuples T1 and T2, randomly we need to select any two tuples from this attribute, also the two tuples from the name attribute. So here, as the values for the roll number 10 and 10 are same, I am going to consider this as the first tuple. So here in the place of X, I am replacing it with the roll number. T1 dot roll number is equal to T2 dot roll number. So in the first tuple, the value which we have under roll number column is 10. And under second tuple, the roll number column, the value we have is 10. So if the values are matching, then there must definitely exist the tuples, both the tuples under name column, because we are checking for this name column. T1 dot name is equal to T2 dot name. So under T1 dot name, what is the value you have? We have Raju. Similarly, under T2 dot name, what is the value we have? We have Raju. So here we have the same value. Here also there exists the same value. So when this condition is satisfied, you can say that roll number tends to name. These both are functionally dependent to each other. So we have identified the first option is functionally dependent. Here you now let us move on to the other slide and know what is full functional dependency and partial functional dependency. Here, if X and Y are attribute set of relation, Y is fully functionally dependent on X. If Y is functionally dependent on X but not on any proper subset of X. Right now, I am going to take an example to let you understand what is full functional dependency. Here, assume that we have attributes like A and B. and this is going to determine the value for C, right? C is an attribute which is functionally dependent on these two attributes, that is A and B. Now, if C is identified by A, then you cannot say that it is fully functional dependent on A and B. Similarly, if C is identified by B, then also you cannot say that C is full functionally dependent on A and B. It is that the value of the C must be determined only with the combination of the values of A and B. If the value of the C is also identified with any of the value of A and B attribute, then we can say that C is not full functionally dependent. Full functional dependency says that the value for the C must be identified with the combination of the values of the set of attributes A and B, partial functional dependency, which means we are going to identify the value for C with the help of any of the partial key. If there is a case that B is able to identify C and if A is also able to identify C individually, then we can say that C is partially dependent or partially functional dependent on the attributes A and B. Next, we have different types of functional dependencies, namely trivial functional dependency, non-trivial functional dependency, and multi-valued functional dependency. Firstly, what is trivial functional dependency? A tends to B is a trivial functional dependent if B is a subset of A. Now, here we are going to consider some example, say roll number, comma, name. This is going to determine roll number. Yes, if we know the roll number and name, then we can easily determine the roll number. That means the information for this roll number attribute is already supplied. Then we can say that the roll number is the subset of this set. Yes or no? So thereby, this can be a trivial functional dependency. So likewise, we have something that is roll number and the value for the roll number is also identified. The same value for the same attribute can be identified. This is also a trivial functional dependent because we are supplying the roll number information and we can easily determine the roll number for trivial functional dependency. There is no need to check in the table that it is correct or not because it is always correct as the dependent value is always available in the determinant. A tends to B is a non-trivial functional dependent if B is not a subset of A. Now let us consider this example relation and let us find out what is non-trivial functional dependency. Here I am going to take roll number column tends to name and check whether this is non-trivial functional dependent or not. Here we can say that these two attributes are non-trivial functional dependent because all the values for the roll number column are what? They are unique. So we need not find whether they are functionally dependent or not. So as said in the previous slide, functional dependency is verified for the columns if the values for the columns are same. In this example, for roll number column, the values are unique. So thereby you need not check whether roll number and name are functionally dependent or not. So here we say that this is a non-trivial functional dependent. It's multi-valued functional dependency. A tends to BC is multi-valued functional dependent. When can you say that? If and only if there exists B tends to C and C tends to B are not functionally dependent. Are not functionally dependent. Now let us understand this by taking an example. I'm considering roll number, identifying name, comma, marks. Now you have to check whether this is multi-valued functional dependency or not. Remember, multi-valued functional dependency, the dependent will contain the more than one attribute. Whereas at the left-hand side, that is determinant contains only one attribute. So thereby, in our example, A is replaced by roll number and B and C are replaced by name and marks. Now we have to check whether it is multi-valued functional dependency or not. Now what you have to do is, you have to check all the values for the roll number are unique or not. Now as said before, the values under roll number column are unique. B is replaced by name. So name tends to C, means what? Marks. Now check in the table whether name column is having the unique values or not. Similarly, marks are having unique values or not. Here, Ramu and Ramu, we can find the same names, yes or no? So thereby, how you have to check whether they are functionally dependent or not? T1 dot name is equal to T2 dot name, then there exists T1 dot marks is equal to T2 dot marks. So T1 dot name, you can consider any random tuples. In this example, I'm considering the first tuple and the fourth tuple. So here T1 dot name, we have Ramu, and under the fourth tuple, we have the same name Ram, right? As there are same values given for the same attribute, you are checking for the functional dependency. If they are unique, you need not check whether they are functionally dependent or not. Then we are going to consider the tuples under marks column. So here the first tuple under marks column is 90 and second tuple under marks column is 50. So thereby, as the values here are not same, you can say that this is not functionally dependent, which means we have proved one. B tends to C is not functionally dependent. Also, you have to check for the other condition, that is C tends to B is functionally dependent or not. If these two conditions are not functionally dependent, then you can say that this one is functionally dependent. That is, roll number tends to name comma marks are multi-valued functionally dependent. Now we are going to see the properties of functional dependency. One is reflexivity property, augmentation, and transitivity property. After that, we have two attributes, namely A and B. Okay, A is a set of attribute and B is also a subset of A. Then we say that A tends to B is functionally dependent. Example, roll number, comma, name. This is set of attributes under A. Okay. And if there exists B, which is a subset of A, assume that we have name, then we say that A tends to B is functionally dependent. That is, roll number, comma, name tends to name. Name is functionally dependent on roll number, comma, name. So this is our reflexivity property. Now we are going to learn what is augmentation. There are two attributes, say A and B. It is functionally dependent if and only if you are going to add one extra attribute to both, that is determinant and dependent. Then there exists a new dependency, that is AC tends to BC. The forming of this kind of functional dependency is one of the property, that is augmentation property. Transitivity says that if the value of B is determined by A and the value of C is determined by B, then the value of C can also be determined by A. This is known as transitivity property. Now, among these three properties which we have under Armstrong's axiom, we are able to derive another rules from it. And those rules which are derived from these axioms are known as inference rules. So which all inference rules we have? Namely union, composition, decomposition, and pseudo-transitivity. Firstly, let us learn what is a union rule. If A tends to B, here A and B are what? They are the attributes, okay? If the value of the B attribute is identified by the value of A attribute, if it is functionally dependent and A tends to C is also functionally dependent, simply we can say that A tends to BC is also functionally dependent. Union means what? A tends to B, A tends to C. You're combining both the attributes which are present at the right hand side and forming a new functional dependency. Composition. What is composition? The name itself specifies what? We have attributes, namely A and B. Assume that A and B is functionally dependent, as well as C and D is also functionally dependent. Now, we can write AC tends to BD. AC tends to BD is also functionally dependent. So this is about the composition. Decomposition means you're breaking down into smaller other attributes. So here we have A tends to BC, which is a combination. Now I'm breaking down, or I'm dividing it into A tends to B and A tends to C. So now we can say that these two are in functional dependent to each other. This is about the decomposition. Coming to pseudo-transitivity. Here, if A tends to B is functionally dependent to each other and BC tends to D is functionally dependent to each other, then we can say that AC tends to D is also functionally dependent to each other. What do you mean by this? Here you can see A tends to B is functionally dependent, right? The value of B can be identified with the value of A. That means this value is dependent on the value of A. So thereby, in the place of B, I am replacing it with A. Now what you get? AC tends to D. So this is also functionally dependent. And this can be achieved with a rule known as pseudo-transitivity rule. So all these are the rules which we have extracted from the three Armstrong axioms. What are they? Reflexivity, augmentation, and transitivity. We have another topic which is very, very important in functional dependencies. And the topic is known as closure set of functional dependencies. Let us see what is it. Closure set of functional dependency F is a set of all functional dependencies which include F as well as all the dependencies that can be inferred from this F. And this closure set of functional dependency is denoted by F plus. I'm going to take an example to let you understand what closure set of functional dependency is. We have a relation say R with several set of attributes say A, B, C, G, H, I. And we have a functional dependency F, which contains several set of functional dependencies. Let me write down A tends to B, A tends to C, CG tends to H, CG tends to I, B tends to H. Now I'm considering A tends to B. Here the value of B is identified by A. And also we have B tends to H. Now, with the help of transitivity rule, what can I write here? We can frame a new functional dependency that is A tends to H. A tends to B, B tends to H, then A tends to H, which is a transitivity rule. Similarly, we are going to consider CG tends to H, this one. CG tends to H. Also, we have something CG tends to I. Now, with the help of union, what can you write? CG tends to HI. Union is used to combine both the attributes. So thereby H and I are combined together to frame a new functional dependency. Now I'm going to take one more, that is A tends to C. This one. And let us see whether we are able to identify a new functional dependency from this. Another thing which we have here is CG tends to H. What can I write from this? As A is determining the value of C, which implies this particular C can be replaced by A. AG tends to H. Can I write like this? Yes. So this is what this kind of functional dependency is derived from which rule? Pseudo-transitivity rule. Similarly, we have CG tends to I. This is one functional dependency. And also we have A tends to C. Now, what can I write from this? CG tends to I and A tends to C, which implies AG tends to I. AG tends to I. It is because here I am replacing the value of C with A because the C value can be identified with the value of A attribute. So when C is replaced by A, we get a new functional dependency that is AG tends to I. This is again from which rule? It is from pseudo-transitivity rule. Right. So which all functional dependencies that you have derived from this set of functional dependency, now the combination of the given set of functional dependencies along with the functional dependencies which you have derived will give you the closure set of functional dependency. Thank you.